we have done 2 exercises from scratch on how to perform a single rotation to restore the balance of the tree. Let's now talk about the cases where we might need 2 rotations in order to restore the balance, especially when the A, B, and C 3 notes actually do not actually slant the same way. One case would be, let's say we got A, B, and C. You can see from A to B, we slant to the right. B to C, we slant to the left. In that case, we have to do the so-called double rotations. And in this case, eventually we want to promote the C up 2 levels back to the root. That's what we want to achieve ultimately. But to do it, we want to, first of all, perform a so-called right rotation. Think about when from B to C, it's really slanted to the left. That's why we want to do a right rotation first. So C and then right rotation will become the middle note. And then A to C slanted to the right. So that's why we want to do a final left rotation to really let it become the root. So that's why we want to perform a second left rotation over here. So C becomes the root. One way for you to think about it is to think about we do a right rotation on the lower note, and then we do a left rotation on the middle note. The other way to think of it is to think about we want to promote the lower note up 2 levels. So the note will just become the root. Once it becomes the root, exactly how to organize a subtree accordingly should be according to the in-order traversal. Let's think it this way. Let's say over here, the in-order traversal will be T1 A, T2 C, and then T3 B, and then T4. But if you look at this one over here, what should really go before C in the in-order traversal? That should be exactly T1A and also T2. So that'll be T1A and also T2. And what should really go after C in the in-order traversal? It should be T3, B, and T4. So that's exactly T3, B, and T4. That's really consistent with how we illustrated in the single rotation case. So I'm going to adopt this later convention. When we do the exercise that require a double rotation, I will simply start with this initial scenario over here, which will require the double rotation. And then I will go directly without the intermediate step to this one over here. And just notice that, right? You can definitely do either what I'm going to show to you without the intermediate rotation. We can do one with the intermediate rotation. It's completely up to you. And of course, always remember to check the in-order traversal sequence. That should be the same. Doesn't matter how many rotations we do. After the first rotation, after the second rotation, the in-order traversal for the tree will always be this particular sequence. That's always important for you to keep in mind. Alrighty, let's now do the exercise together. And let's now try to start with part A. So part A over here, we're going to insert 44, followed by 17, followed by 78, followed by 32, and followed by 50, followed by 88, followed by 82, and followed by 95. Let me double check. So 44, 17, 78, 32, 50, 88, 82, and also 95. You can double check the search property as well. I'll leave that to you. And of course, let's draw the external nodes over here. And we'll fill out the balance to check whether or not it's actually balanced. We'll do that in a moment. Okay, this part over here. This is now the third exercise we are doing for the rotation. So hopefully you're feeling much more comfortable right now. Right? It's not difficult, but just need to be very patient and also precise about the details. Okay, let's now fill out the heights. Okay, of course, we want to answer this question. Is it balanced? Let's now fill it in. 0, 0, 0, 0, 0, 0, 0, 0, 0. 1 here, 1 here, 2 here, 1 here, 1 here, and then 2 here, 3 here, and 4 here. Right? Hopefully you are pretty much proficient like me right now to do fill out the balance. If you got any trouble understanding this part, refer to the earlier part for the lecture or reach out to me. Is this balanced? Check quickly. 0 0 0 0 1 1 0 0 0 0 0 1 1 2 2 3, and all the child height differences are less than or equal to 1. So that's why the high balance property is maintained. So check. Let's now try to insert the tree, insert a new node, and the one we want to insert will be 85. Let's now do it. Let me copy this tree over here, and then I'm actually going to insert the new node. And let's see if this insertion is going to result in some yield balance, in which case we have to do rotation, and we got to decide what kind of rotation that should be done. All right, so we're going to move on to the next part, which will be to insert 85, and that's going to be part B. Okay, let me paste the tree over here. All right, good. And where should we put 85? 44, 85 larger than that. 78, 85 larger than that. 88, 85 less than that. 82, 85 larger than that. So it should be this external node, which is converted into internal. So let's now, okay, smaller. Let's now delete this part over here. That's the part we want. So that should be 85 over here. Underneath it, we have the external nodes over here. You know what, for convenience, let me just copy this part of the tree for later. This could be a good starting point for rotation for later. Okay, let's now take a look. Let's now fill out the updated balance. 0 0, and this should be 1. 0 1, so this one should be 2. And 2 1, 2 1 over here, so that should be 3. And also 1 3, so this one should be 4. And then 2 4, so this should be 5. Apparently we have created some yield balance node, but let's see exactly where. Let's identify, first of all, the ancestor path of the inserted node 85. So that'll be starting from 85, 82, 88, 78, 44. So that's the ancestor path, which is very important to identify. Ancestor path. Where is the first unbalanced node on the way to the root along the ancestor path? Is this node balanced? It is 0 and 0. That's fine. Is this node balanced? It is 0 and 1. That's fine. Is this node balanced? It is 2 and 1. Fine. Is this node balanced? No, because 1 and 3 over here. Right? So that's why we have to actually identify them. You can see over here, the difference is actually 2. So this is the first node that's actually yield balanced. This is the first one over here. So this will be A. And then the next one will be the child over here along the ancestor path. This will be B. And the next one will be C over here. A, B, and C. What about T1, T2, T3, T4? We should also do that as well. And if you try to look at the slanted, the way they slant, A to B, B to C, that's really corresponding to what we said earlier on the slides, A to B and B to C over here, right? And we need to identify T1, T2, T3, and T4. Okay, I'll do that. Let me use a different color over here, if I may. How about, let's say, orange. Okay, so think about this part over here. This part over here is T1, and this part over here is T2, and this part over here is T3. Okay, and finally this part over here is T4. Okay, let me just label them. So T1, T2, T3, and T4. We got all the components we need before we consider the rotation. We got A here, B here, and also C here, and also we got T1, we got T2, we got T3, we got T4. Let me just help you a little bit more. Let me help you a little bit more closely. If you try to do in order traversal, T1, and then A, and then T2, and then we got C here, and then we got T3, and then we got B, and then we got T4. That's what we have, right? Just don't lose the big picture. That's what we are really doing, okay? So this will be the in order traversal, but exactly how we're going to do the rotation, let's see the way the three nodes are slanting. A to B, slant to the right, B to C, slant to the left. So that's exactly the pattern we have to follow from here, right? Exactly, right? We should really do a right rotation on C first, and then followed by a left rotation on the same node, which has now become the middle node. But you can think about, we just go directly from here to over here. I think that'll be easier to understand. Let me put it down over here. It's a conceptual rehearsal. So what we have is, let me just help you a bit over here. So we got A, and then slant to the right, we got B, slant to the left, we got C over here. And of course here we got T1. This part over here is T1. And this part here, T2 and T3. T2 and also T3. And this part over here is T4. I think having this is very handy, because you can see that's exactly A, B, and C. A, B, and also C over here, right? And also you got T1, and also you got T2, and you got T3, and then you got T4, right? And what should that be transformed into? This one here, after A, right, left rotations on the lower node C. This is the one we actually want to rotate twice. Eventually, C will become the root. What should really come before C in the in order traversal? That's what you would want to think about. It's going to be T1A and also T2, right? And also what's going to go after C in the in order traversal is going to be T3B and then T4, right? That's what you want to notice. And once we understand that, it's going to be split into two parts over here, left and right subtree. And for the left, it's going to be rooted at A, and then we're going to get T1 and T2. T1 over here, and also we got T2 over here. And for the right subtree, it's going to be B, and then we got T3 and T4. T3, and also T4. Right, let's now try to highlight them. That's really the reminder you want to have for yourself. It's really important to get very straight about what's to be done. Right, so that's the part. And let's now do it. So we're going to move to part C. And part C is actually going to perform a right-left rotations on node, the lower node C, which is which one? This is a C node, 82, right? This is node to be rotated twice, so that it will become the root. Ultimately, you'll become the root for this particular subtree. All right, that's what's going to happen. Right, let's now try to paste the tree from before. Right, so let me just make it smaller over here. Okay, maybe even smaller. Okay, so that's good enough. This one over here. And let me just remind you very quickly again. Okay, so we got 78 over here. This is A. And we got 88 over here. This is B. And we got 82, which is C. Okay, I can just make the circle a little bit smaller over here. This will be C. I'm going to recalculate the heights later after rotation. And we also got this part over here is the T1. This part over here is really T1. And if I can just touch. Okay, good enough. T1. And this part over here, T2. And this part over here, T3. And this part over here is T4. Okay, that's what we have. And overall, we are actually going to modify this particular subtree. You can think about the entire right subtree of the 44 is going to be modified by the rotation. Okay, so I'm going to do what I used to do. I'm just going to move this part over here away so we will know where to put things back. Okay, let me just get rid of this. So that one should be 78 over here. All right, so what should we do? Think about this pattern here is really matching A, B, and C. A, B, and C, and T1, T2, T3, T4. T1, T2, T3, and T4. Now notice one case over here. It's now more interesting because in the earlier exercises, all of T1, T2, T3, T4 are just external nodes. But now T3 and T4, you can see they don't have to be just external nodes. T3 is a subtree rooted at 85. T4 is a subtree rooted at 95. Right? But we're going to still do the same manipulation. Let's not do it. So what's going to happen is C is now going to become the root. So I'm going to move C first. C is actually over here, right? Let's put C over here. And then we're going to get A, T1, T2. A is over here. Okay, let me put it here. A is going to be here. And then also we got B. B is going to be over here. Right? You can see I'm trying to set up C, A, and B. And T1, T2, T3, T4. Let's not do it. So T1 is actually going to be this one over here. So T1, and then T2 is only just the external nodes over here. And also T3. The diagram is not the prettiest that can be ever produced, but at least it's clear, I'm hoping. Okay, T3 and also T4. I can make some optimization in just a moment. Okay, let me just wipe out everything that's not needed. You should really just make sure the big picture is being followed, and you should really also try to do exercise on your own. T3, T4 over here. Okay, let me just move them a little bit over here. I think that'll be good. Good. Let's now connect them. So C is actually going to have the left child over here and also the right child over here. So this part here, C, if you do it in order traversal, A, C, and B. A, C, and B. And then we got T1, T2, T3, T4. Let's now connect them. So A, the left child will be T2. And then, sorry, T1. And here T2. And then T3. And then T4. All right. And let's now try to see their balances. Okay. For now, let me just remove the T1, T2 label because they can be a little bit distracting. So let me just remove the tree over here and T2, T3. And there's one more thing I would like to show to you. Just bear with me for another few seconds. But if you want to refer to the label, you can just rewind the video to see where T1, T2, T3, T4 should belong to. Right? So that will be almost the final tree. I want to do one more exercise for you, which I didn't quite do in the earlier part. If you try to do the in order traversal, what are you going to have? You're going to get 50, 78, and then 50, 78, 82, 85, 88, and 95. So it's still a sorted sequence, right? Alrighty, let's now update the heights. Let's see. So for this part here, we still got Let me just also try to fix this part over here. So 0, 0, 1, that one's good. 0, so 1, 0, maximum 1, so this should be 2. This part here should be 2. Right, and then let's see 0, 0, this should be 1. 1 and 1, so this part should be 2. Right, 2 and 2, this part should be 3. 2 and 3, so this part here should be updated to, actually that one should not be updated. So we got 2 and 3, so this one should be 4, so that's okay. Now, is the tree balanced? That's the question. Is it balanced or not? The answer should be yes, because now if you take a look, 0, 0, 1, 0, and also 0, 0, 0, 0, 1, 1, and also 2, 2, and also 2, 3. You can see the differences between the heights of the child nodes are all within 1. So that means we are okay for the balance. So indeed, it is. Check over here. Alright, so it's a very detailed walkthrough about the double rotation, but you can see the principle is really the same. I think this might be where you want to try. You can think about, we just kind of collapsing the intermediate step. So we just simply show, starting from this initial configuration before the double rotations, we want to see what the final outcome it should be. But the principle will be, you want to make sure that in order traversal over here still match what used to be before the rotation. Okay, that's something you can definitely check over here. That's something we spoke about many times already. Alrighty, so that's about the the third exercise. I want to point out to you some extra exercise you want to do. So the next one will be the rotation, also double rotation, but it's going to be left followed by right rotation. The principle will be the same. Over here, you can see we got the lower node over here, but now we slant different ways. A to B and then B to C. To the left and to the right. So that's why we want to do a left rotation first on C. So now it becomes the middle node. And then we want to do a right rotation on C, so it becomes the root. But the principle will be the same. And for this part over here, maybe I wouldn't record a video for the walking you through the solution. I think this is really the chance for you to really practice on your own. And I'm going to put, if you go back to the iPad notes over here, for now, I'm just going to say this is the exercise you want to do. Over here, I'm going to leave the empty page for you. And the next page, I'm going to put down the written solution that you can actually check your answer against once you complete the exercise. I would suggest you do it, otherwise you will have to do it the first time in the exam.